I hope everyone is having a great day and enjoying the conference. My name is Caitriona Kelly, and I work at Stripe as an engineering manager on our Secure Frameworks team. Today, I'll be talking to you about how we build some large-scale security frameworks and deploy them across Stripe. So I guess we'll start with, what is a security framework? Well, framework is a very overused term and covers all manner of things. But in this context, it's a set of abstractions in code that provide security guarantees for common threats, helping teams secure their services. These abstractions are composed of middlewares, libraries, or services that are built into our foundations. Teams utilize these frameworks as it allows them to focus on their products and guards them from common security implementation concerns, speeding up their design and development. These building blocks just work, and their implementations are hidden, simplifying concerns. So why build one? Well, NIST defines 5 functions to manage cybersecurity risk: identify, protect, detect, respond, and recover. Security frameworks sit in the protect function. They provide systematic protection from classes of vulnerabilities. By building into our foundations, security is always on by default. They give you a centralized view, a view of inventory and protections within the scope of the framework. This is invaluable for determining exposure as new vulnerabilities come to light and evaluating your coverage. They're high leverage. There's a clear owner for observing industry trends and ensuring that protections stay on point, making the extensions needed as technology and threats evolve. And as new threats come in, you solve them once, getting the benefit everywhere. And best of all, it simplifies security. The security primitives are good to go, shareable and reusable. Teams can focus on additional risk or nuance their product domain brings in, but ultimately, each team isn't trying to solve the same problem many different ways or be experts in all security domains. Before my team started, Stripe had a good level of coverage for higher risk assets, but we wanted to have a consistent bar both internally and externally. We wanted to avoid copy-paste config from what was previously best practice. Not only did we want to say we were fundamentally protected at a point in time, but also be able to support that claim every day going forward. As a consequence of building frameworks, we drive the number of security incidents from non-standard or missing controls to 0 over time. We've built a number of frameworks, some just simple libraries to some more complex architectures. Today, I'll use our web security framework as an example as I go, as it was more complex and posed more interesting questions. First and foremost, I don't believe you can enforce behaviors or code standards across a large org without the backing of a peer-reviewed security policy. We must agree what the standards should be. By peer review, I mean other security teams and perhaps some strategic partners for a user's voice have reviewed the policy and their feedback incorporated. This also helps later if there's a disagreement on a stance as we've built consensus early. And these policies must be discoverable. A random file in a filing cabinet is unlikely to be sought out or used. We used a security guidance site that returned hits highly in search results. We also link to policy in appropriate places like how-to guides or error messaging. But all of this is nothing if the policy cannot be understood. It should be clear and concise. 20 years security experience should not be prerequisite to understanding of the policy and its intent. So here I've included some screenshots of our policy for CSPs, taking out the more sensitive information. Now, a CSP stands for Content Security Policy and allows control over what resources can be loaded and used on a web page. The application of a CSP can prevent unexpected scripts from loading, which mitigates most XSS concerns. Now, a security policy could say that every web page should have a CSP and why it's important. But I believe you need to go a step further. We should define what is acceptable content of such a policy in a lot of detail. We defined a traffic light system to help communicate what was and wasn't okay. So green means security is comfortable. Orange, there's some caveats. Consider reaching out to chat or operate within the boundary specified. Red requires a security exception. To the right hand of the screen, you'll see that we expect entries for base URL, connect source, child source, and so on. And within each of these, we define acceptable safe values and are very clear on what shouldn't be used. There's no ambiguity here. We try to make our policies intuitive and referenceable like docs, so areas can be really understood. Users should be able to navigate quickly to the space they need. You'll also notice that we'll have the ability to link to specific sections, very handy when you want to point to someone at a specific piece of content. And the navigation bar on the right also helps with navigation within the page. We also gather direct feedback from users with optional comments that goes directly to the Slack channel of the owning team. Now, security policies should be living things and continually evolve to reflect best practice. The world evolves. The policy must keep up. Security policy should reflect reality. A policy that doesn't reflect reality, that continually gets new exceptions, is useful to no one. Now, exceptions, granted or otherwise, are a good way to understand your reality. Security is one function in a large organization. We take the time to understand the reasoning behind the exception request, which helps us understand our operating landscape more. To give an example, we observed a pattern of exceptions in the scope of cross-environment access. Now, immediately our reaction was, environmental boundaries must be respected, and that's a fundamental rule. And to be fair, we were right. But digging into the exception, with respect to web security, these two environments had the same trust level, and there was good reasons for the access. In reality, we were giving exceptions for this, so what were we doing here? Just creating a friction and security theater. So we rethought. We had taken a too stringent approach and decided to rework to open up in this very specific bounded circumstance. This reduced the friction for future developers as an exception was no longer required, and we clearly called out the risk for other environments and why an exception in those cases would not be forthcoming. If a policy is consistently getting exceptions, then really it's a policy in name only. It may be reasonable to have exceptions, but where there are consistent or regular exceptions, I think it's worth checking in if a policy change is warranted, or perhaps there's missing features, infrastructure, or tools that are worth prioritizing. What we learned was, specific is better. A traffic light system really helped with clarity. And listening to users and understanding our domains helped us iterate on our policies so we had something that worked for everyone. Now, if you're designing a framework from scratch, you would have a lot of options, but when you need to plug into what's operating today, options can be limited. So let's go through two of those that we used. A simple solution could be to create a library that contained the desired security properties and enforce the usage. Some considerations to that. A library will be required per language, and its interfaces should be tailored to that language. So there is an upskill cost to build a spanning development skill set. A continuing question will be feature parity. As you make changes, are you going to make them to all the other versions? And it gets trickier to maintain parity as other priorities come in. Since a library can be used in the most sensitive workflows, and most likely will, finding ways to monitor performance where you don't control the service resource allocations can be problematic. Documenting baselines is a good idea. But in theory, this should be the most performant solution as you've avoided a hop to an additional service. Now, in the case of multi-repo, you may need to require forced upgrades of your library as you make changes over time. And similarly, depending on your org's deploy schedule, you may need to force deploys with the new version. At Stripe, we have mono repos for a small number of languages with auto deploys. So this was a desired architecture to implement, and we used it for our cryptography framework. Another option is middlewares, and this is what we implemented for web security. So considerations include latency, and an extra layer for all traffic to pass through needs to be very performant and closely monitored. Reliability is also a concern. There is now a single point of failure. If a bug is added, there could be a very large blast radius. Further complications are deploy schedules. How are services deployed to pick up new changes? Again, mono repos with auto deploys simplified things a lot for us. And a distinct advantage of middlewares is that they can be extended once you have the initial architecture in place. So we went with the middleware architecture as it allowed configuration of each of the individual components, and so was highly customizable. So CSB, cores, setting default headers were all components. And it was then easy to add others to scale horizontally as we wanted. So what did we learn? There's a lot of options, but it was important to consider the long-range maintenance as well as what would work for the initial build-out. One thing that worked really well was that we considered the framework architecture, as that would allow us to plug in different elements. This meant we could add new middleware as we wished and own the migration to enforcement. And libraries can be a simpler solution to distinct services as it reduces the hop and limits infrastructure costs. So moving to controls. There are a number of layers to an effective control. We started with code ownership of the config, meaning we owned all the config files. So we would code review all changes before merge. Now, this was a good initial step to guarantee that changes were as we expected and we could enforce adherence at code review. And Stripe tooling allows code ownership of files and packages so anyone can propose a change, but only code owners can approve it to merge. This has its own friction, but it's a good first step. The next two are test types within the repository itself. Unit tests verify that your framework is working as you would expect. Perhaps some tests verifying specific behaviors and actions you're trying to avoid. Static coverage validation are broader tests, also in local repositories, that check the state of the code as opposed to a specific behavior. Here you would include verifying only entries in an allow list can complete a legacy function. Another use case we had was to ensure that all UI services were configured for the various web security middlewares, and anything not covered had a UI response type blocked. As all of these are in the repository, engineers get quick feedback if there's an issue. And a well-written failing test resulted in someone trying to fix the breaking behavior, which is the outcome we want. To confirm the coverage we needed, we also added dynamic coverage validation. This involves checks at the edge to confirm there was no unexpected traffic patterns that we hadn't caught. Starting out, we would log the issue but not block until we built up confidence, sending warnings to our runner for investigation. However, I've been talking about friction and cost, and having a team review all changes is not a good way to spend their time, and it's just blocking deploys where all changes are in policy. It was a real source of friction. It also adds a human error component. What if a reviewer misunderstands the code or just misses something? It's not ideal, so we had to fix that. So we designed a config validation step that could be run on all repositories that verify changes for adherence to policy. CI would fail if something was added that was prohibited, but all compliant changes would pass on through. This meant we no longer needed to own all the config, we just needed to own the exception files. And this was big to build out as we needed to cover all repositories and languages where we had the frameworks. However, its impact was undeniable, as this allowed us to remove code review requirements on all config files, and people only needed to concern themselves when they wanted to add something that required an exception. Digging into config validation a bit more. So we defined parsers for each repository so we could translate into a common format. From there, we would run a set of rules to verify entries match the security policy. In effect, we had codified our security policy and were running compliance checks every build cycle. Now, for the eagle-eyed among you, for CSP, you'll see the rules match to the CSP policy in the earlier screenshot, so it all ties together. We also made the binary available in all dev environments, so it can run locally to debug issues without the need to kick off remote builds. So this had a few benefits. We could always add a new repo and apply the same rules. All we needed was a config parser to translate. Cross-checking against approved exceptions ensured no false positives and also no bypassing. We could also control the binary content, and as it was part of CI, there was controls for tampering. And users only experienced a friction if they were going against policy, and we wanted that to be a friction. So at this point, there's pretty good coverage. Was all friction resolved? Unfortunately not. Finding out at CI time that your change is an issue is not ideal. From a user's perspective, they've worked on a PR, did all the local testing, polished the code, pushed, and thought they were done. And then a CI failure tells them that they're not. Bad times. Errors need to be closer to dev time. The config validation is an excellent control. It verifies compliance, but it does not provide an optimal user experience. The furthest away from development time a control is hit, the higher the cost and friction to fix. So what did we learn? Starting with the very rough edge gave us invaluable information to actually design the config validation. Users' first instinct when encountering a failing test locally was to fix the test and not ask for an exception. The further out the friction, the more costly it was to resolve. And config validation in CI was very effective and was an observable way of understanding friction. So at this point, we have comprehensive controls, but we don't actually want engineers to hit them. And at Stripe, we take our operating principle of users first very seriously. Secure Frameworks users are Stripe engineers. With that in mind, we want to meet our users where they are. If you have to step out of your work to look up a policy or get a failing build when you're about to merge, then we've added a friction. Instead, we focus on embedding this information and bringing this to where the user already was. In practice, this meant some ID plugins, so config schema validation, autocompletes. We would warn on policy violations, and it was important to not just say what was wrong, but instead why we were blocking and suggesting alternative paths. We create a nifty debug tool, so a Chrome extension flagged blocked traffic and proposed resolutions, including line numbers on where a fix was needed. The screenshot demonstrates a violation report to a user doing some local testing that a CSV change is needed. And we also define simple default configuration. For documentation, we created tooltips for config, giving explanations and pointers to docs for more thorough reference material. We embedded security snippets in other teams' docs, and in general, we aimed for thorough, well-written, and well-laid-out documentation. The aim was not to need the docs for simple use cases, but be crisp and discoverable for more complex scenarios. So what did we learn? Web security was our first framework, and we biased to getting the controls in first before improving the developer experience. This caused a friction, but resulted in a huge lift in our security posture. It was the right call at that time. More recently in projects, we've optimized the dev experience before enforcing the control. And this has brought us more social capital in the org and resulted in better outcomes, but it is slower. An ecosystem of tools has improved developer experience. We considered them a toolkit that we can append to as a framework necessitates it. And docs are hard to get right. A careful reveal of complexity is our goal. So we've defined what good is and what it looks like. We've stopped new bad invocations, and we've optimized the user experience. And now we have a decision. What do we do with all of the legacy usage? Choices range from a blanket accept of legacy usages and fixing forward, going backwards and fix everything. And an obvious benefit of only fixing forward is no migration, but it does mean accepting the risk for existing assets. It also means that there's a legacy control to continually maintain and confusion as people try to use existing code in new areas and find themselves blocked. A counterpoint is migrations can be very costly and could cause breakages. We wanted to completely raise the bar for web security, so retroactively going back was important. But even after deciding to do a migration, there are considerations to how it's executed. Central migrations, as much as possible, had the most success. For web security, we migrated every service to the web security framework architecture, with each middleware configured as off. And then we migrated as many as we could to on, where the change was trivial. It was a high lift, but a big jump in coverage. This simplified the migration for those remaining, as could be completed independently, and there was less context to know of internal framework workings. And generally, everyone was happy. We then transitioned to a fan-out model. We asked teams to turn on enforcement for middlewares where there was nuance of the area to understand. For example, we created a CSP policy for all services, but there was entries that violated our new standards, and we asked teams to resolve those. This required program management, and certainly wasn't free nor easy. In asked to teams, it was important to include why we specifically were looking for, clear definition of done, why it was important, a rough sizing, clear migration guides, and expected due date. Doing a couple first as a pilot helped us smooth paths, clarify the information we were given, and make sure that there was no documentation gaps or rough edges. This did require project management to close out the migration, and we closely tracked adoption by making sure we had a nice graph that was going up and to the right. Today, we aim for somewhere in the middle. Centrally migrate as much as possible, but where testing is unclear, we asked the team to take the PR, test, and merge. And it's been very successful. So what did we learn? We could have centrally migrated more at the start. We've been more bullish on this lately, and ultimately, the smaller we make asks, the more likely and more quickly they were to be done. Also, while we thought asking teams to just do the work would leave us freer for the next project, it was still quite costly on our team. We had to have excellent migration guides, be available for questions, and generally do ticket follow-up. And central migrations are an easier sell for organization buy-in, and also limited impact to other teams, but they're not always possible. And that completes my talk for today. Thank you all for being here, and I'm happy to answer any of your questions. Just feel free to submit in the chat. I guess I'll take advantage while I'm waiting for some questions to come in. There's a number of roles going in Stripe in security across authorization, privacy, offensive security, and some don't actually require security experience. Also a program manager in security risk management, so feel free to apply, stripe.com/jobs. Thanks, Grace. So Grace's question is, if I had to start from scratch again, would I do anything differently? We tried to do so much at the start that we thought it would be easy to ask teams to just run loads of migrations, and we didn't pilot enough. If we had, I honestly think that if we had just kind of picked, say, for example, one of the repos and actually done more pilot migrations and done centralized migrations more, and then moved into the other one, we actually would have ended up in the same place, but a lot smoother ride. But we were aiming for a big lift at the start. And it has its challenges. I think maybe another learning was documentation is ridiculously hard. You're trying to capture all nuances, all edge cases, be very careful that you're not just always adding and you're actually deleting and considering the user journey through them. That was definitely, you'll end up with sprawl very quickly. Well, I think we're coming up. Jenkins for our CI/CD, we build a lot of stuff internally, and we have our own documentation platform that our internal tools built out. Sorry, that was Melissa's question. I'm curious what CI/CD and documentation platforms your teams use. From May, devs are always annoyed at having to implement security controls, and I'm sorry. And I'm looking to switch over to the sec side from the dev side. Well, I would kind of think that security controls are guardrails to doing the right thing, and that kind of keeps you doing, like, saves you issues in the future because you haven't kind of screwed it up. So if I would actually think it's actually improving the developer experience for everybody, and I think that's the way you kind of look at it. It depends on the controls. Like, the more friction you add, more people aren't going to particularly like it. But if you can make them intuitive and they're more guardrails to actually help you do things faster, then I think they're a good selling point, and I think you can kind of sell it that way, and that's what you kind of want to be working for anyway, is to actually make things faster safely. All right, I think that we're at time. Thank you all for joining. I really do appreciate it, and please do reach out to me on LinkedIn or Twitter if you want. Enjoy the rest of your conference.